I think we are on. Let's close a couple windows here. And all right. So, um, let's see. One moment here. All right. Yeah. So we're on. Welcome back to Crystal Fridays. So we've been gone for 2 weeks. We are back today, and we are back to talking about our Crystal Docs project. So I'm going to do my normal sort of setup or introduction that I always do. So for folks who already have been on this screencast before, excuse me, it's been a while. So for folks who have already been on this live code before, you've probably heard all this before, but just for new folks, I want everyone to sort of be included and be on the same page. So I'm going to do my little spiel. So if you haven't heard of Crystal yet, go check out crystal-lang.org. And just the basic about the language. It's new. It's definitely an emerging language. I guess when I say new, like it's not new, like, it's started yesterday. Like the first version of Crystal was last week or something, but it's new in the sense that it has some new ideas in it. And something like Crystal has never really been done before. Hey, C Yang, thanks for coming. Glad you're jazzed about another Crystal adventure. So you've probably heard this before, just for folks who are new. Yeah, I mean, it's a new concept, it's a new idea, it's a new language. Closest thing to Crystal that I've really ever seen. A lot of people say this too. It's like Ruby. It's got a similar syntax, feels the same. It's got some similar concepts. But the big two differences between Crystal and Ruby are it's compiled by the LLVM toolchain. So you get like a binary that doesn't need like the Ruby runtime or any other dependencies. You can ship that binary everywhere. You can cross compile it. And then the other thing, I guess there's kind of two. The second thing is it has types. So it's statically typed and the compiler checks types for you. So that means a variable that is a string is a string is a string no matter where you send it, no matter what values you try to set it to, it's always going to be a string. And the compiler checks that and will fail your build if you try to set it to something else. So it's statically typed, it's type checked, and that's super nice for people like me who come from statically typed languages. So me, I come from and I still write a lot of Go. So it's same deal. It's statically typed over there, and that's kind of what I'm used to. And then the last thing is concurrency. So if you know Ruby, you know that Ruby is single-threaded, and so it cannot be a parallel language. And it also has some sort of more difficult facilities to do concurrency with. Whereas Crystal has some more kind of advanced but also easier to use facilities to do concurrency, at least in my opinion. And also before Crystal 1.0, the core team has committed to adding multi-threaded features to Crystal, so then it will be truly parallel, which will be super nice. So, excuse me. So, just as a little aside, if you're wondering why I keep saying parallel versus concurrent, concurrency lets you schedule two different things to be done at the same time. So that's what Crystal lets you do right now. You can schedule things to be done at the same time approximately. But right now, Crystal is single-threaded, like I mentioned. So the things actually don't really truly run at the same exact time because things only run on one core with Crystal. So that's concurrency. It looks like things might be going on at the same time, But really what's going on in the background is they're running on an event loop. So that means that IO operations, like file operations and network operations, they are scheduled to happen. And then the next thing can happen, even though the response from the server or the file system operation didn't come back yet. So that lets Crystal do this thing called time slicing, which lets you schedule like 5 different network operations at once. And then whichever one comes back first, that one gets processed by your code. And then so on for the second, third, fourth, and fifth. So that's really powerful as it is. That's how Node.js works, for example, and other languages too, including Ruby with Event Machine, I think it's called. But there are other languages that are also multi-threaded, and Go is an example of one. And that example builds on the concurrency features, but it also will actually schedule these operations on multiple cores. So I've got a multi-core machine, and so my Go code will run on all of those cores, and all of the concurrent stuff that I write in the code will actually fan out to many cores, so I could actually truly be doing multiple operations at once. So I will leave it at that. I can go deeper. I don't want to go deeper because I want to focus on Crystal. So in this live code, we go through a project. So we did a first project before in the first few live codes back in the day, just to get our feet wet. And now we're doing a real project. I quote it, real project called Crystal Docs. So this is a documentation server for Crystal. So you can go AR//Crystal Docs on GitHub. Check it out. Everything we do today and all days, I will always check it in and push it to GitHub so you can see the code after the fact. So let's go to VS Code. Structure of the code base. Since we've been out for a bit, we'll kind of come back to the structure of the code base to get our bearings again. So we've got our main.cr. Hey ASW, thanks for showing up. Thanks for coming. So we've got our main CR, which is our entry point. We don't really need this, but it lets me start up the server basically on the command line a little easier. Saves a few keystrokes. So we also have our main file. This is a real main file called crystaldocs.cr. So this is where we basically set up our database that has all the documentation in it. And then we also have our HTTP routes. So we've got a get route. I believe this is the only one, if I remember. This is to get documentation. Let's see if I can collapse this. Yeah, that's it. So this one's quite a big one. But let's see. The basic idea is this is to get a shard. A shard is a single dependency for Crystal. It's to get it from either GitHub or, let me rephrase that. It's to get it from our database. And if it doesn't exist in our database, it's to go and grab it up from GitHub, bring it down, download it essentially from GitHub, and then process it. So the way that we process it is we run the Crystal tool against the code, and that will spit out a bunch of documentation. And then we take that documentation and store it in our little mini database. And at that point, then we can serve it out to the client. So this works kind of like a cache, but the only difference between this and a cache is this won't evict anything. So there's no like time to live on this database that we're dealing with. But when there's a miss, it does treat it the same way as a cache. So it'll write it down to the database and then return it to the client. So going down the code, we grab those two path variables from the URL. If you've seen this before, I always spend like 10 minutes bragging about this question mark and how much I love it. I won't do that here. I'll just say, I'll just leave it at this. So this is a Nil check. This will actually force you to check the nil. And that actually is forced via the type system. So the question mark will mean that whatever is returned from this hash map will either be the actual string for the shard name or nil if it didn't exist. So if it's nil, then obviously we are hosed. We've got to bail because we need the shard org and the shard name in order to proceed. So we check for those, and then inside of the else, shard org and shard name are no longer possibly string or possibly nil. They're definitely string, and the compiler guarantees that for us. Then we put together our shard VCS URL. I guess, yeah, last time I think we just hard coded it just to make some progress. But this is just going to basically be the zip file for our shard, our shard information that we passed in. So same deal. We check to see if we've got the docs already. And if we do not, then they will be nil. And that's when we go in and do all of our fancy work. Then I think, yeah, we've got an else here. The else is basically just return it from the database. So this is our, I'm not really going to say happy path, but this is the path that we expect we will execute more. Because really, we should only go in the if once. So once meaning when the user first, when anyone first requests the shard, that particular shard from this server. After that point, it'll be in the database, and from that point on, we'll just go into this else. So on the other hand, the if is the one that's important to us and most interesting. So we go down, we try to get the shard VCS URL. We'll go into our HTTP utils in a second. Check for that, check to see if the response is nil. If not, then we go and looks like we're going to log it. We're going to try to get the body from it. We're going to try to read the zip file. And then right now we're just going through the zip entries and printing out the file names in the zip file. So I actually don't remember how far we got last time because it was a while ago. So let's just try running it. Crystal docs, and then I basically put in the main because I can do this instead of more keystrokes. So I'm that lazy. So we'll run it, and oh, not crystal docs. We just want to run crystal. Crystal run. And there we go. And then we can curl this server at this path, shard org shard name. So since we already hard coded this, let's check out good old CodeStake. So that's I always say this. That's like the best GitHub username ever. So one day I'll get CodeStake to join the live code, just because I'm a fan already from that person's GitHub name. So thank you for both your database that I use and also for your awesome GitHub name. So yeah, by the way, the database that we're using is called Numite. That's this one right here. So let's do a curl in our other tab. Oh, what port did I use? 3000. CodeStake Numite. And error. Couldn't download code zip file, no IO. So where's that being printed out? No response. We got past that then. Couldn't download zip file, no IO. Okay. So we are trying to print out the first line of it. And oh, I guess that's the first line. Oh boy. All right. Where are we doing that? So I just want to make sure. Okay. Let's restart our server. Head back over. Couldn't download. Okay, so there's something up. Let's also figure out what's happening with our response. And I don't remember how to get the response code, but let's see. We got to trace it up to what is http utils.getReturn. That's in here. So yeah, we get this HTTP client response back. Response status code. That's the one. So, oh yeah, we wrote this because we had to follow the HTTP redirect, which GitHub always gives you when you try to download from that URL that I hard coded. So, oh yeah, we figured out this the Crystal built-in HTTP library. This thing, it does not follow redirects. I think, yeah, we found a GitHub issue for that in the Crystal repo. So it doesn't follow redirects, so we rolled our own. And then, yeah, we follow the redirect, we call recursively this function, and then if we did not get a 302, then we return a response. So yeah, this thing might still return an error. So we've got to do response code, response.status code. So let's see what happens with that. Start it up, call that status code 200. Okay, so why, oh why, is there not a IO? Let's go over to our Crystal docs. So when you go over to the Crystal docs, or when you want to get to the Crystal docs, you go to the home page, click on docs, and then there's two things here. Language reference is like the walkthrough. Like you go through here, and this is like a walkthrough. You can go from front to back. So if you're thinking about learning Crystal, this is what I did. And I still come back to this too as a reference. But the one that I look at more often these days is the API. So let's see, what do I need to do? I need to look up what the HTTP client.get does, because I got to figure out why that is not giving me a proper IO. So let's go check out HTTP client. Client. HTTP client. All right. So without a block, an HTTP client response is returned. The response's body is available as a string. So why did we need an IO though? We had to feed it into the zip reader. Body.lines.first. Okay. Response body io.getS. So, okay, let's go check out exactly what the, I guess body IO returns an IO. So we got to figure out how to get all the stuff from the IO. I think getS might do it, but I'm not 100% sure about that. So IO, let's just do HTTP response. Oh, yeah, it's here. HTTP client response. Body IO returns an IO. We're going to just click through. Let's see. Do we have getS in here? Reads until delimiter found or limit bytes are read or the end of the IO is reached. getS. Reads until delimiter is found. Reads a line from this IO. So how do we read the whole thing? getS to end. Okay, let's try that. Response body is response.getS to end. Okay. Okay, so yeah, we should get that 200 status code still, and then let's see what the entire response body is. Hopefully this is going to print out a massive, oh yeah, we need response.body. Let me just interrupt myself there. So yeah, okay. So we should get a 200, and then I expect to see a bunch of gibberish, which is going to be the zip file. So, hey, I don't remember if it's El Barasti or E Barasti. Either way, hello. Thanks for coming. Good to see you again. So yeah, all right. Here's the moment of truth. This will help us with some debugging. L. All right, L. I'll try to remember that. Dot body. No. We did this because it's no IO. Oh, we don't even have an IO yet. So I'm actually just going to print out body because that's right. We didn't have an IO yet. That was a very roundabout way of me basically writing the exact same code that I had before. No IO. All right, so there is a huge body. Yeah, this even went past my buffer, my terminal buffer. So that looks like a thing, a zip file thingy. So what is going wrong? Why do we not get an IO? What is it called? Nope, not here. We need to go back to our HTTP response. Body IO is not doing the right thing. So if body is doing the right thing, then let's see how we can shove the string, which is coming from body. Let's see how we can shove that into this zip reader. So I'm gonna go check out this documentation, zip reader. And what do? We have to pass something to .open. Open takes in a file name. No, that can't be right because we're passing it an IO. So let's see. You can pass in an IO to new or an IO to open. So how do we create an IO from a string? So let's go here. Let's click back through. You know what? We're going to open this in a new tab. Let's click back through and figure out if we can create an IO from a string. Here's a simple IO on top of a bytes. I would rather not create my own IO. Oh, check it out. All right, string builder. .new. Well, is this going to do our thing? Similar to IO memory. All right, let's click through to string.build. All right, what does that do? String.build, .do stir. Okay, that looks fine. Let's try this. This looks like we're gonna get a string.builder or a string builder class, which itself is an IO, and we can shove our body string into that thing, and then we will have an IO that is the string. Let's try it. So we've got the body. There we go. Just let's still print that out, and then we're gonna do our thing here. String.build.do, that's the block. So let's put that body string in there. And now we've got our string. And by the way, there is a body, this thing, where it'll return that, you know, maybe the body string or maybe nil. I'm just gonna skip that for now. I'm gonna be a bad citizen of Crystal and not check for nils. So that means we can get rid of all this stuff. I won't call it garbage, but I will call it stuff because I don't want to deal with it right now. And let me name this body IO. And I'll have to clean this up later to try to do what now? Oh yeah, try to do the actual checks. So let's see, we're matching up our ends here. There we go. All right. So now let's see what happens. I think I might have needed to, let's see, do I need to import something for string? Oh, let's see. I can never remember. Oh, looks like I'm good. Okay. Ooh, we're getting HTML back. Did we break something? String contains null byte. Maybe we need to not use a string and use bytes instead. You know what? Let's go to this in the browser so maybe we can actually see that HTML. Nope. Okay. So we've got a null byte. So it looks like we have to somehow get the body as bytes. Oh yeah, what line was that on? Null byte, null byte, null byte. Where's our code? Is our code even in here? Oh, maybe not, maybe not. All right, so yeah, this is, I guess, just, oh yeah, here we go, line 55. That's weird. It's all the way here in commented code. Yeah, I'm just gonna have a wild guess here and say that we tried to get or we tried to put the big zip file into a string and that messed everything up. I'm guessing that null byte is the reason that things got messed up. So we're gonna go to a client response. We're gonna see if we can take see if we can take bytes out. We already tried IO, that didn't work. So can we take bytes out? Class methods, no. Instance methods, yes. String, headers, status. And we might be relegated back. Yeah, we're relegated back to trying to deal with IO. Alrighty, so I can still print out that body. Let's just not do that actually. Body IO equals resp, maybe response dot body IO. And again, I'm not going to check for nils. And since we did this before and then we checked for the nil and it failed, I am assuming this will still fail as well, but at least we're going to start with this. So, okay, there we go. Broken. Okay. So why are we not getting an IO back? We might need to go in and look at the source for this to figure it out. Unless there's some documentation here that tells us, I guess the documentation would probably be in client. Client, body lines first, get with the params, within a block. Oh, within a block, a response body is returned and the response body is available as an IO. All right, so I guess we have to do it inside of the block, which is fine. So we are going to do our get. We've got to fix up our get a little bit. And doing that, I think we do this. How do we do blocks again? So oh, I forgot how to do blocks. You know what? Let's do this a little bit differently. Just because I don't want to waste time getting figuring out how to do blocks, we're just going to copy some code. Just like a good software engineer, we're going to copy code. Okay, so, well, wait, there's a better way to do this, actually. Let's just put the code in here. Client get URL, and we're going to do response, and then in here, we're going to do our thing. And then get is going to do we're going to recall get response equals this equals get URL. Oh, where do we do this? Let's see. Headers, we get our new new location, so basically just this. And then we've got our maybe response. I'm just going to put the type there just so I don't forget. That's the cost of explicit types. Look at that. Boom. There's a lot going on there. But I don't really have to put this. I'm just doing this to remind myself because I'm still a newbie. So if maybe response is nil, then let's just return nil. We'll have to clean that up and do an error later on. Otherwise, we're going to do our block. So yeah, I got to figure out how to do the block again. Do response. Oh, never mind. We can do this. Return the IO because we're in the block here. So we are going to do maybe response body IO question mark. So yeah, we'll return the IO or nil. Did I line everything up right? No. Oh man, what did I do? If response status code is 302, otherwise, oh, I got this wrong. If there is a new location, if there's no new location, then we return nil. Otherwise, we do our get new location. And then if it's not a 302, then we get our, then we do our thing with this extract the IO dealio. This thing always trips me up here with Crystal. Nil is the class, and then lowercase nil is the instance of that class. I never remember that. I never remember which one to use. But I used it here because it's already here. So that was easy. Again, copying code. Don't you love it? And we're going to return the maybe IO. So we're going to end that else. We're going to end that else. And what else are we going to end? End the block. And then are we going to end the function? Yes. And then we are going to end the whole module. Cool. Okay. So now the body IO. All right. What are we doing? Okay. This now returns an IO or a nil. We're checking if it's nil. Otherwise, we're going to just jump right to the zip. We're not going to check the response code anymore. We'll have to clean it up later. I'll even write some documentation here. We're going to take a block in from here so that the caller can deal with the HTTP client response in that block and still get access to the responses IO. All right. So that's a to-do. We'll do that another time. Let's move on. All right. So we've got our IO, I think, I hope. Body IO equals response body IO. And then we'll do a to-do here. All right. Let's try it. Maybe new location, HTTP line 20. I bet I got some ends wrong. What does it say? Read before assignment to local variable. Oh, maybe response. No, I don't need that. This is what I need. Just response. And actually, does response inside of the block, is it a maybe or not? I can't really tell. It looks like it is not, just because they're not checking for nil at all. So I don't need this or this. I just need that. And then response.bodyIO, I deleted that question mark. Yeah, I think this is it. Let's let the compiler tell us. Nope. Undefined method in Crystal Docs line 41. Body IO is maybe response.bodyIO. Oh, I don't need this either. We need to check for the body IO because this thing is now returning IO. We don't need this. We don't need this because we are checking for a nil IO. And there we go. Yeah, less code is good. I think it's going to be okay now. Yeah, it's okay. Cool. Still nothing. We're still not good. Closed stream. Why, oh, why? Oh, maybe it closes the stream after you close the block. All right, we're going in. We're going to check out how to do blocks. So, reference. This is where I always go to remind myself how to do blocks. And is it inside of proc maybe? Proc represents a function pointer. Ooh, something's weird with their docs page now. Proc type. Invoking. No, no, no. Maybe it was down here. Blocks and procs. That is what we are looking for. Here we go. That's how you take in a block. To define a method that receives a block, use yield inside of it, and the compiler will know. That's close to what I want. Can't remember how to do this. Yield expression is similar to a call that can receive arguments. No, I don't want that. There is a way, I think, to specify that you want to take in a block and you can say what the type is of the block. That's what it is. All right. So I'm just going to copy this and we're going to figure out what we want the block to take in and return. So we definitely want it to take in HTTP client response and put this on new lines here. And I think what we want it to do is just return a generic type. But let me remind myself how to do generics. Okay, class T, generic structs and modules. I wonder if we, yeah, we can't do it on functions. Okay, so what do we want it to return now? The block is going to return maybe just nothing. Because maybe we're going to just do all the rest of the work in here. For now, that's what we're going to do. So we've got a response. We're still going to do our redirect. Otherwise, we're going to call the block. Yeah. Have this thing just return nil. And I think that's how you call the block. Going back to the block here, did I? That's what it was. There was, I think it was down here, the way that you call it explicitly, not a yield, not type restrictions, not break. Maybe I missed it. Not next. Unpacking block arguments. I probably missed it. It's probably up here. I just saw it before I clicked over to the new thing. Nah, let's just try this. Let the compiler tell us. Expecting token, not comma. Where did we? Oh, that's what it was. Please. Expected, that's perfect. Expected to be invoked with a block, but no block was given. So let's put it inside of a block. So Eric.dev, I keep staring at the pending update on VS Code, itching to press install. You can't tell like to run bleeding edge, can you? Do I have a pending update somewhere? I'm actually, if I do, I'm gonna wait till after the screencast to do that. Um, I too look like running on the bleeding edge, but um, let's write some crystal right now. So body IO is going to be IO nil. This is not what we want because this block is going to return nil and the function is going to return nil. And then, so yeah, okay. So our body IO is now in here and we're getting that from our response body IO. We're going to check if it's nil. And then if it's not nil, do that. Steve St. Martin, it's only a bug fix release. All right. Here we go. You both convinced me. If everything breaks, it's on you. It's on both of you. Opening remote. All right. It worked. It worked. Both of you, I took a risk on you, but it worked. ASW, people often ask why my Visual Studio icon is green. Code Insiders for life. I do not run Code Insiders during streams. I guess I do that. I'm more conservative than some when it comes to my IDE. But yeah, maybe I'll take a walk on the wild side sometime. If I see any of you do streams, I'll follow suit. Just hold me to that. All right, so back to this. We've got our body IO, might be nil. We check that, and then we do our zip thing. All right. Eric.dev, I've run insiders on streams before too. It didn't end well. Well, you're not inspiring confidence, but I think I'm still going to try. I might as well try. You all have converted me to... I guess the wild side of streaming with IDEs. So this is on all of you now. Oh yeah, okay. Let's get back to this. If you couldn't tell, I'm obsessed. HTTP line 20. Oh, same deal. So get is expected to be invoked with a block, but none was given. So coming back here, we have to pass our block to our recursive call. That makes sense. And then, yes, we're calling the block with just the response because that's what it expects. Okay. Wrong arguments are given for get given to expected one. Maybe we have to do this. Missing Elbarasti missing the ampersand. Maybe. Let's try that. That would make it a lot easier. Undefined method block. Maybe I need that. Maybe I need ampersand there as well. No. I know there's a way to call it. And you know what? I did this in the other project. The project before this one. Because... oh, it's block.call. Okay. Thanks, Albarasti. I was going to go back to my crazy functional programming failure that I did with Crystal last time. Last project, I mean. I did learn a lot from it, but I'll just do a little shameless plug here. Go to air//cprox. Go into the source directory, and then option.crystal and result.crystal have all of this code that I was trying to do, like functional programming in Crystal. And I think I got a lot of it, but I ran into barriers when I realized you can't, as far as I know, you can't have generics on methods. You can only have generics on classes and I think modules too. As far as I know, that's true. Please correct me if I'm wrong. I'll jump for joy because then I can probably finish this library. Anyway, back to here. Oh yeah, so thanks to you, Elbarasti, it compiled. All right, so let's see. Let's see what we got. No doc. Okay, we got further here. We got further. I should look into for all. Okay, you have my attention. Crystal Lang for all. For making methods generic. Let me just leave a tab open. Type restrictions. Okay. Yes. I remember for all now. Okay. Sweet. Okay. I will come back to that after the stream. Maybe I can do a stream about it later once I wrap my head around it. Because that would be cool if I can make methods generic. Even here, like, I guess I could do it here and have the block return whatever it wants. So I wonder if I should go down a rabbit hole right now. What do you all think? Rabbit hole or let's try to finish this? Vote. Yes, +1 or -1? Maybe not. Anybody else have an opinion? Rabbit hole or not? +1. All right, we're tied. Who wants to be a tiebreaker? Rabbit hole. Oh, Elverosti, I don't know. Do So the Dolphin is a +1. Steve St. Martin is a +1. Sig JE is a +1. Oh, Do So the Dolphin's a -1. All right. I guess I'm going to make this not a democracy this time because I'm going to keep going on this and not wrap. Oh, we have another +1 from Eric.dev. I was just about to make a overriding decision. Okay. Okay, we're doing it. We're doing it. We're going down the rabbit hole, y'all. So here's what I want. I want basically like this. I want a generic type. This is definitely not the crystal. Oh, +1 means finish. Oh. Huh. I was saying +1 meant rabbit hole. All right, I'm doing rabbit hole. We've got 15 minutes left anyway. And we got down to where did we get down to? We got down to here. Okay, so we got past all of this code. It all worked. And I know that it worked because we actually printed out all of the contents of the zip file. So the next step, and I'll just do this next week, it should be pretty easy. The next step is download all of this stuff into a temp directory and then run that crystal docs command. And all of that code is commented out here. It's like put it into a temp directory, run crystal docs, take out all of the docs. Like it prints out or it outputs like an HTML file and JavaScript and all this stuff. Put each of those docs into the database and then we're almost there. We need to also have a static file server, but so that it can serve up all that stuff. But like we're almost there with that. This code basically needs to be uncommented and then all of the things are broken. But at least it's there and we can fix stuff. We've got a foundation. So rabbit hole time. We have 13 minutes left. Let's check out this for all thing. And you know what? I'm going to start with my code because I think I tried to do for all. Maybe. If I remember right, it was in result. Yeah. Block T to V, result V for all V. So did I have these? Did I have T or, yeah, did we have T or V anywhere up here? We had a T, so maybe for all. Elbarasti is for all. I'm assuming for all is the way to declare that V is a method local type variable. So I'm going to try that. Here we go. It is. All right, cool. So we are going to return a T for all T. Is that how we do it? Sure. Unknown word for all. Well, it's known to me, so let's try it out. Expecting const, not parentheses. Oh, no parentheses. That's how you do it. Okay. Yeah, just def get and then for all T, no parentheses. Does this work? I wonder how I say that it needs to return a T. Oh, that's how I do it, I assume. All right. I think I might be calling this wrong though. Oh, no, I'm not, because I am returning nil implicitly. Oh, I have to remove the T before the for all? Does it still, Alberosity, does it still return T though? If I want it, like if I want to return the value that the block returned, do I still need to do this right here? The colon T? Okay, you see what I mean? Okay. Yeah, I'm just going to put explicit returns. Oh, I'm going to actually say T or nil, because I might need to return nil here. Yeah. Okay. Actually, that wasn't that big of a rabbit hole. So what I want now, I want to do files. Oh, how do I do an array again? I want to do files as like the array of files that were in the zip. So we're going to do this. Files equals list. Files entry dot file name. We're going to put to do in here. Actually, I'm not going to put it to do in here. I'm going to try to actually, yeah, I'm going to put the file names in this list, but I'm actually going to create the temp directory here and write the files into the temp directory. So let's just do pseudocode first. New temp directory, and then write to dir name, and then the entry dot whatever it is, contents. So that's going to actually write the string down into, oh, we've got to do dir name plus entry dot file name. And I'm going to do one of these, make them on new lines, so it's easier to read. So we're going to write the file into the dir name. I'm actually going to break this out into a new variable. Fully qualified equals dir name, and then a slash, and then file entry dot file name, and then we're going to write to dir, and then we're going to do fully qualified, and I'm going to entry dot contents, and now let's pull this out. The dir name is going to go there. And actually, I'm going to get rid of the files array. I don't think we really need that. I'm going to write to dir, and then we are going to return dir name. So we're going to call this dir name is a string, and we are going to return it from right there, from the else. So if we go into the if, we're bailing out of the whole program. Well, not really. We're bailing out of the whole route. Just because we're going to halt. Halt is just going to tell Kamal, bail out, just stop executing code in the route. And it's not really going to do anything. I think it's not going to do anything here. Maybe we should do empty string there. I don't think this code's ever going to execute though. I think this is going to just tell Kamal error, like send an error back to the client and don't run any more code. Maybe. So let's just see though. This should fail because all this stuff is just right here. This is all bogus code and this. But at least I want to see if maybe we'll get past this. Yeah, can't return from captured block. So that is probably related to this. So I think I can get rid of that. Yeah, okay. All right, so 6 minutes left. Maybe we can figure out how to do a temp directory. Just shooting in the dark. temporary redirect, temp file. That sounds pretty good. File, 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 temp file. All right. The files will be placed in dir, which defaults to the standard temporary directory. Hey, S2Poc62, thanks for the raid. And JR Boss, thanks for the raid as well. Welcome, 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 welcome. S2Poc62, Crystal is a programming language. It's not what you may think and what other people have told me they thought. It's a programming language. It's pretty new. And you can go to crystal-lang.org and check out more about it. We're doing a project in Crystal right now. Yes, only not slow. Ruby-like syntax, only not slow. So we've got our dir name. We're trying to figure out how to make a temporary directory. Where did I see that? Self temp file. Oh, yeah. Files will be placed in dir, which defaults to the standard temporary directory. Dir.tempter. So we have to figure out, yeah, we've got to make a dir.tempter first so we can pass that into here, and also we can set it to the dir name that we're returning out. So dir name equals dir.tempter. Yeah, dir.tempter. Oh, we don't need the parentheses. And I think we might have to require dir here. I think. Well, maybe not, because this is in the core API. S2Poc62, Ruby-like but not slow. I thought that was Python. Yeah, Python is a little faster, I think, but this is compiled. This is down compiled to machine code, so it makes it, depends on the measure, makes it a little bit faster. At least a little bit faster, possibly a lot faster. So dir name equals dir.tempter. Let's see if we get past that line or I messed something up. Yes, we did. All right, so we've got our dir name. We are going to then call file.tempfile, prefix and suffix, foo and dot bar, and temp file is going to create a temporary file. Prefix and suffix are appended to the front end of the file name respectively. They may contain directory separators. Yeah, we don't really want to do that. We want to write a real non-temporary file name into the directory name. So I think what we want is to write the zip. I'm pretty sure zip is an IO implementation. We want to write that IO into a file name that we control under dir.tempter, I think. I'm pretty sure we do, because this is going to have the code. We really want the code file, like the actual file names of each code file. So we've got fully qualified. That's going to be the file name under the temporary directory. So really this is what we have to implement. And we're probably going to do that next week. To do, implement right to dir. Okay, so 2 minutes left. I'm going to just wrap it up here. Thank you all for the raid. If you want to learn more about Crystal, I kind of alluded to this. crystal-lang.org is the place to go. If you just go to the homepage, you can kind of learn a little bit about it. This is the syntax. And then also, if you want to go to this project that I'm working on, it's github/ARSCHLES/Crystal Docs. You can just kind of check out the code. This is a documentation server. So like the point of it is to serve up docs for any of the dependencies you care about in Crystal. Yeah, so that's going to be it. I will be back live coding this same project at the same time, 10 a.m. Pacific Standard Time, at the same place, twitch.tv/ARSCHLES. So my Twitch name is the same exact thing as my GitHub name. So with that, Eric.dev is in this channel right now, I think. It's Eric, D-O-T, ERIK, he is going to be streaming in like 1 minute. There you are. Yeah, so Eric.dev is going to be streaming in 1 minute on his Twitch channel. He's going to be doing IoT stuff, um, really cool IoT stuff with like face recognition and natural. I think he's doing some AI stuff. He might be doing some natural language processing stuff. Um, a lot of it is over my head, but I love watching it because there's awesome demos. So do check him out. It's a really cool stream that he does with one of his coworkers as well. So go check it out. Go over there right now. It's an awesome stream. I will be there too. So, all right, y'all. I will see you next week. Same time, same place. Bye.